Okay, let's get this over with. It's paper 2 for SLs. And just like the paper 1 video, a lot of these questions I'm going to skip because they're part of the HL paper, which I've already done in my other videos. But question 1 is not in the HL one. Let's see what this is. Okay, we have a diagram. Here's A in the center, B is on the outside. Then we need to find the radius, so that's pretty straightforward. We're just finding... Oh, I need to turn on my tablet. We just need to find this distance from A to B. So this is just Pythagoras, essentially. There's a formula in your formula booklet. You essentially just subtract the x values, square them, you add the y values, and so on and so on. So like 6 minus 4 squared plus -1 minus -5 squared plus -3 minus -9 squared. Okay. And then get your calculator. Okay, 6 minus 4 is 2. 2 squared is 4. -1 plus 5 is 4. Squared is 16. Plus 6 squared is 36. Okay, square root it. There you go. 7.48 maybe? Where do I want to write this? Right there. Okay, hence find the total surface area of the solid hemisphere. Oh, they usually don't ask too many surface area questions. Okay, so we want the total surface area including the top because it's solid. So there is the circle on the top, which contributes to the surface area. And then there's like the outside of the actual hemisphere. So like this part. Okay, and then these are straightforward. You have pi r squared for the area of the circle, and then a full sphere is 4 pi r squared, I think. And then this is half of it, so that's 2 pi r squared. And then of course now that we have our radius right here, we can just put it in and calculate the total surface area. Okay, so pi 7.48 squared plus 2 pi 7.48 squared. So 527. 527? 3 significant figures, right? Units squared. Okay. We're gonna skip number 2. This is in the HL, I think it's question number 1. If not, question number 2. Yeah. Okay, and then question number 3. Yeah, this one's new. Okay, we have a binomial expansion question. Pretty straightforward. Our exponent is to the power of 11, so that means that the number of terms we have is always plus 1 of that exponent. So 12. And then it says here in the expansion, the coefficient of x to the power 7 is 1320. So if we follow the binomial expansion formula, any term is going to be 11. Well, here, let me just pull up the actual formula sheet because because I am not 100% on what it is. Okay. Here. So this is the binomial theorem, right? Expand it out. And then NCR is this formula right here. Not that you really need to know it as in SL. There is a function on your calculator to calculate this. So 1, 2, 3, 4, whatever, right? Okay, so here it is. Hidden inside of the expansion, which I always found kind of annoying. But this is the formula for any term in the expansion. So what we know is that when we actually expand this out with our value of k, you have this as your term, 1320 times x to the power of 7. And then what we're going to do is we're going to equate these two, and then you can compare them. So essentially, we know like x is a, and then that means that we can figure out a couple of things. Also, 11 is n. And then 1320 is NCR times b to the power of r. And our goal is to find r right now. And then what we do is we also know that our exponent for x is 7. So n minus r is 7. Which means that, well, oops, n is 11. So this means that r is 4. Yeah. And then now that we know that r is 4, we can figure out the value of k. Because we know that k is related by the stuff I boxed in the red. 1320 is equal to 11c4 times k to the power of 4. Okay, and then we can just solve for k. So 1320 divided by 1320 divided by 11, oops, 11c4. So that's 4, and then we take the 4th root of this. So you get 1.41. I'm pretty sure you can leave it as exact value too. So maybe something like this is fine. But it is paper 2, so you can calculate this and give it to 3 significant figures. I don't know which one's better, to be honest. I think they both give you full marks. Like, I don't like decimals, but this whole paper is decimals, so whatever. Okay, question 4 is in the HL, but someone who commented in my other video did point out that you can actually find the variance using your calculator. Because I've just been doing the HL formula, because variance very rarely shows up in the SLs. I don't even remember that it was in the SL curriculum. Let's see. Only for binomial? Yeah. Oh. What the? Why are they asking you for variance if it's not Is it required? I don't know. You should double check that and complain once the official paper comes out, of course. But anyways, we can calculate these things, the mean and the variance, using a table. I didn't realize that we could do that. So what you can do is quit. Get me out of here. You can put your x values as list number 1, 1, 2, 3, 4, 5, 6, right? And then what you can do is you can put your probabilities as a second list. Like, I knew we could do this for frequency tables. I didn't make the connection that you can also do it for probabilities, which are kind of like a frequency of how often x shows up. And then once you plug those in, you can calculate the one variable statistics, and then you list your frequency list as list number 2, and then list number 1 is of course your list of actual x values. So I don't know if I can actually do this right now because of the numbers I put in. But here's all of your stuff, right? You have your mean, and then this is why I usually approach it with the HL formulas, because I'm pretty sure variance is like barely touched upon. But variance is the square of the standard deviation. So first you need to find sigma, and then you square this number to get the variance. I don't believe it's actually listed here, because no one gives a shit about variance. It's stupid. I spent like 15 minutes ranting, like trying to explain what it is. Probably not too much success. But anyways, this one we can skip. That's HL or SL in the HL paper. This one we can also skip. I'm pretty surprised that this one, at least part B, was in the SL. Not to say that you can't do it, like it uses purely SL curriculum, but it's like a tough question. Okay, and then that leads us to our long answer. So let's see, we have a pretty standard trigonometry wave. And then let's see, here's your A value, here's your B value, here's your D value. So A is related to the amplitude, so we know that the amplitude is 2 over pi. D is our midline, as you can see here as well. And then B is related to our period. So our period is 2 pi compressed by B. So 2 over 3. Okay. So, oh, I already did part A. I always do these first because, like, you might as well just write them down. Okay, part A is done. Part B, point P has the coordinates of this. State whether P lies above, below, or on the graph of F. Justify your answer? Huh? I mean, okay. You can just plug in X. And then, yeah. Plug it in here, right? You're gonna get a Y, and then you compare the Y with this one, because the Y you get from here is where the graph is at this X value, and then if it's like above or below, then you can see here. I don't know. Why don't I just do this? Okay, first radians. Okay, 2 over pi sine 3 pi 1.63. Can I do it like this? Let's see. And plus 2. Sure. So you can see our Y value right here is negative 0.63. So 26. Did I do this right? Am I in radians? Yeah. Oh shoot. Okay, 2.2, right? And then this is 2.16, so point P is below. Okay, why is that 3 marks? Sure, whatever. Okay, line L1 has this equation, write down the gradient of L1, so... What do we got? We got x plus 11 is equal to 6y, 1 over 6x plus 11 over 6y. So here's your gradient, 1 over 6. And then L1 is normal to the graph of f at 1, 2. L2 is tangent to the graph at here. Find the gradient of L2. Okay, so let's say like this is point A. Line 1 is normal, which means perpendicular to the tangent line. So here's L2. This one's L1. And then because we know the gradient of line 1, we can figure out the gradient of line 2. This is just the negative reciprocal, so negative 6. And then hence or otherwise, find the equation of L, so this is pretty straightforward. We have our slope, and then we have our point right here. So we can put into point slope, or point gradient formula, y minus 2, negative 6, bracket x minus 1. Okay. And then here's line 1 again. Intersects the graph at another point B, where the x-coordinate is greater than 1.5. Find the coordinates of B. Okay, so easy enough. We have the equation for both of them, so then you can use your GDC to find their point of intersection. I'm going to use Desmos, just because it's faster. So the first one was what? 2 over pi sine 3 pi x plus 2. And then it was 1 minus 6y plus 11 equals 0, I think. Okay, now point A is 1 and 2. So this is point A, and then they're saying point B is this one right here, right? No, not that one. This one. This one. So 165. And then 211. Okay, then the shaded region enclosed by this graph of F, line L between A and B, find the area of the region. Okay. So we now want to find the area between the two graphs. Now, it is a little bit tricky because which graph is on top of the other one switches. So for the first shaded region, L1 is above the graph, and then afterwards, for the second part, the function is above the line. What that means is that if you did a simple integral from A to B, like point A to point A, point A to point B, so like the x value of A to the x value of B, and you did like L1 minus the function, you're not going to get the actual area of the shaded region because this is going to be a positive amount and then this would be a negative amount because of the way the lines are switched. So this would be positive and then this would be negative, and then of course when you add those together you get a smaller area than what it should be. So what you do is you just take the absolute value. Very, very similar to like a total distance traveled type of question. That's the fastest way to do it. I would not split this into two integrals, but you could do that if you wanted to. That takes too much time. Okay, so with that being said, I'm gonna call this F. And then I'm gonna call this one G. And this was 1 over 6x plus 11 over 6. Okay. And then, right, we take the integral from 1 to 1.65, let's say. And then absolute value, nope. Of f of x minus g of x dx. Okay. So there you go. This should be the actual area of the shaded region. Again, all those you can do in your GTC. This is just faster if I can type it on my keyboard. So 253. Okay, nice. Question 8. And then question 9. Okay, question 9 I'm not going to do because this is in the HL paper. That's kind of a tough one for SLs, but completely doable. What the heck is this? We have discrete random variable, state 2 conditions required for x to be modeled by binomial distribution. What the hell? So a binomial distribution is like flipping a coin a bunch of times, and then you see how, and then you're like counting how many heads show up. And then of course there's going to be, it'll look like this, where you're going to have more heads, like there's more, let me draw it, right? Let's say you're flipping like 10 coins, then you're gonna most likely see, like, if you were to repeat this experiment a few times, it's not very likely that all 10 are gonna be heads. Same with you don't get any heads. You're gonna get a lot of instances where you get around 5 heads. So that's a binomial distribution. What do you need then? You basically need independent events or trials. Independent trials, and then they all have the same probability. So then that's probably the 2 things they're looking for because it's worth 2 marks. Anyways, okay, we got water slide, 2, Daifang, Torbellino, sure. Okay. 37% will go ride Daifang. Saturday, this is how many people go to the park. Find the number of people that are expected to go to Daifang. Well, 37%, right, of this number. Okay. $37% of 1900. 730. Okay, find the probability that 312 people will ride Daifang. Between this many people inclusive will ride Daifang. Okay, so now this is a binomial distribution. Out of the 1900 people, we want to find the probability that 712 of them ended up taking the ride. The probability that any single person goes on this ride is 37%. And then obviously each visitor's decision is made independent of any other person. So we are finding the probability that 712 people will take this ride. So this is a binomial probability out of 1900 people, with the probability of each person going on this ride is 37. What's the probability that 712 people go on this ride? And then there you go. It's not that high. 17.3%. Or is that 1.73%? Well, it's only 37 for one individual person, so like almost half of them going is pretty unlikely. Okay, between these two people inclusive will ride the Daifang. Oh, at least they're nice. Oh, but it's inclusive, so we should be a little bit more careful. Okay, so this is like a cumulative. I'm gonna draw normal just because it helps me see it. But we just found out actually no, I'm not gonna draw normal. We just found out the probability that 712 people are gonna go on this ride. And then we need to find the probability of 684 until 712. So we are going to add that to the probability of 711, 710, and so on, all the way until 684. Okay. So what I'm gonna do, and then this is just because my GDC, this is a cumulative, and my cumulative only has one X value. It will only tell me the upper boundary. So my binomial cumulative distribution function will only tell me up to a certain amount. Inclusive. So what I can do is I can do this. $7.12. Okay. And then this is essentially going to tell me 0. It's going to add probability of 0 all the way to probability of 12. Now, I don't want all the way from 0. What I need to subtract is I need to take away 0 to 683. Because I want to keep 684 onward. So what I'm going to do is subtract this, right? Binomial CDF. So minus binom CDF until 683. Right, and then what does that leave me with? That leaves me with 684 to 712. So minus 683. Yeah. Paste. So there you go. 498. Cool. And then let's talk about Torbolino. I'm gonna take a prediction and it's gonna be normally distributed. Never mind, it is not. Okay, I'm just gonna delete this. Okay, Torbolino, 61% of visitors. It can be assumed independent of Daifang. Find the probability that a person will ride both Daifang and Torbolino. Okay, that's easy enough. Since they're independent, Daifang is 37%, Torbolino is 61, so we can just multiply them together. So 2257. Okay, next Tuesday, N people will visit the theme park. The probability is at most 500 people. The probability that at most 500 people will ride the Torbolino is this. Find the value of N. Oh, I'm gonna eat my words about you guys not needing to know the formula for combinatorics. Or do you just guess and check this? Okay, we're gonna guess and check this. So at most 500 people is P, right? And then we want to find some upper boundary. N. And then this is going to be 0.693. Or wait, hold on. Oops. At most 500. I think I had a similar question in the HL, and then like I don't think you guys can do this if it's a cumulative, like algebraically speaking. So we're just gonna guess and check. So there are 500 people this time? No, there are N people. Okay, we need to guess how many people are gonna visit the theme park. So I'm just gonna start with like 2,000. And then Torbolino is 61%. And then we know that there's 500 people that we would like to go on the ride, at most 500. Okay, boom, 0%. Okay. So that means that my 2,000 is too much. So let's start with 900 instead. Very unlikely. Okay. Let's try 1,000. Even more unlikely. Okay. That means I need... It's getting smaller. I need it to get bigger. I don't know. Is there a better way to do this? Let's do 600 people. What? Oh my god, okay. Delete 600. 1. $700? Really? Am I doing something wrong? Okay. 900. It goes from this to this? Oh well. Okay. Okay, so more than 800, but less than 900. So stupid. Okay, cut the difference. 850. Okay, 850 is too much. So 825. I'm just gonna keep taking the middle value. Okay. 825 is still too much. Okay, 813. Ooh, close. Okay, 813's... I need to go a little bit lower. 812, probably? Nope. This is such a waste of time. Okay, what about 811? Nope. And 809? There it is. So yeah, just keep guessing and checking until you get the actual number. 3 marks. Guessing checking's fine. Because it's a paper 2. You can literally just say use GDC to find n, and I think you'd be fine. Because again, I don't think you guys can do this algebraically, especially at an SL level. Alright, and then again, I'm skipping the last question because that's on HL paper, and that's it. Overall, I don't know. I would say this exam, this paper was above medium. Yeah, I'm gonna say it's above medium. But paper 1 was pretty easy, so I think. Okay, that's it. Thank you for watching. Who knows when the next one will be, if I ever do a next one, because now my source for these papers has quit as well. And yeah, if it happens, it happens. If it doesn't, it doesn't. Okay, bye.